Let's understand the concept of level translator for op-amp. Level translator is the third stage of op-amp. As you know that op-amp is a multi-stage amplifier. The main use of level translator is that it shifts the DC level present at the output of the second stage of this op-amp to 0, and this output is further fed to the next stage. So why do we need such shifting? So if you recall from your previous classes, when we cascade to BJTs etc., we always put a capacitor in between. So the capacitor serves the purpose of blocking the DC or shifting the DC level to 0. Since those capacitors are not allowed for in IC integrated circuit technology, because it's a big, or it will make our IC not will be little bulky, and we want our ICs to be very compact. That is why we cannot use capacitors. Instead we use shifter level translator. So these level translator will make the DC component at the output to 0. And why do we need such shifting? Because DC present in the input signal would change the operating point or the biasing point of the transistor. Correct? And secondly, DC level present, if the DC level present at the input signal is larger than VCC, or DC level plus the maximum component of AC would become larger than VCC, then what would happen? Then your transistor might not be in active region, right? Because we already consider that if we are using NPN transistor, such transistor, this will be in reverse bias and this will be in forward bias. So if our input to this becomes, for any instant, becomes greater than VCC, then this junction will not be forward bias, and this will violate the condition that we are using this transistor as an amplifier, which happens only when your amplifier is in active region. So in order to satisfy these two things, what we do, we use a level shifter at the third stage of the differential amplifier. So ideally we should use a capacitor here, right? Capacitor. But why we now don't use the capacitor? I just explained it to you. Yeah, so one can also ask, sir, why we should also put a level translator here? Why we are only shifting the DC component present here? So the answer is yes, we should, but ideally, but it will unnecessarily increase number of level shifters, and only using only one level shifter serves the purpose that since after this we use a level shifter and then we pass it to class C amplifier. So we want that the output here, the DC component here should be 0, and if there is some DC component here, we can somehow manage that. So we are more bothered about DC component here, so which we make to 0, and then we further feed to the next stage, which is a class C amplifier. These two things we have already studied in our class, that what would be the VC here or the output voltage here. We have seen that here we had some DC component as well as AC component, but here the DC component present at the output was larger than the DC component present here, right? Why this happened? Because of the first some DC component, because of this DC component present here, the operating point will set some operating point, then further we have VCC, right? So it will further shift our DC level. So I hope this make sense now. Why do we need level translator? Then question is, how can we design a level translator? So level translator can be designed using emitter follower with a voltage divider. Very basic, the simplest level translator can be designed using emitter follower and along with the voltage divider. So this is a emitter follower circuit. Why do we need emitter follower? Because we don't want AC component of your input signal to be amplified. We just want whatever input we provide, we get the same output in AC, but we just want to shift the DC component, right? That is why we are using emitter follower along with the voltage divider. So the output of the second stage will be fed to it, which is the output of dual input unbalanced output amplifier. So we take the output at VC2 of the second stage and we feed it to this. And we choose our R1 and R2 value in such a way that we get 0 here. So whatever out VC2 comes here, the DC component will become 0 and the AC part will just pass. So if our VC2 is like this, so this DC level shifting will become 0, will come down to 0, and the AC component will pass as it is. So this is the purpose of using level translator. So how should we shift, or how should we choose or select the values of R1 and R2 so that we get a 0 volt DC here? So for this, what we do, we make sure that the current which is passing through this, is I. So if it is 0, then I will be equal to 0, because the current through R1 and current through R2 must be same. So current through R2 is 0 minus VEE divided by R2, correct? And and if the DC level at this point is VDC of the second stage, so VDC of the second stage minus VBE should be voltage here. So current through R1, R2, R1 plus R1 and R2 both will be VDC2 minus VBE divided by plus VEE divided by R1 plus R2. This is the current which will flow through this, right? And since they are in series, both currents should be equal. See, we are ignoring the AC component present in here because we only want to shift the DC part. So we are only doing the DC analysis in a way. So we have to choose the value of R1 and R2. This is given to you, this is given to you, this you know, this you know. So you have to choose value of R1 and R2 in such a way that this equation is satisfied. So you can fix R1 to, for example, some 10 or 1K, and then accordingly you can set R2, right? Which will give you the answer that how should you choose R1 and R2 in order to make level translator. To further improve the performance of level translator, we can use level translator can be used in combination of emitter follower along with constant current bias or current mirror. Constant current bias, or you can write it different separately, that you can use emitter follower along with current mirror. So these two configurations we'll see later.